this here would be a horizontal asymptote. We all know that already, right? So you're going to feel this way often with this stuff. You could do this entire section using old knowledge, the old way that you've learned how to do this. But we're now going to look at it again from a different perspective, which is what calculus is. So if I call this L, we know that this occurs when the limit as x approaches plus or minus infinity of f of x equals L. And I'm going to put a box around it to make it stand out. So the L we're talking about is just right there. And I think there's not a whole lot else to explain with that. Take a look at this. The limit as x is approaching positive and negative infinity. So looking at like this part here, we're just saying as our x values go in that direction and as our x values go in that direction, the limit as x approaches positive or negative infinity would be equal to that Ly value, whatever that is. Good? So that's the first thing. And the limit as x approaches infinity of 1 over x, I've just chosen this because, I'm going to put a little star beside it. Are you all pretty familiar with the function 1 over x? Want to show me with your hands? Like, what does it look like if we graph it out? Yeah, both sides are going, right? So it's doing that on both sides. So that would be equal to 0, to tie it in with something that's familiar. Okay, so then let's take a look at some examples. If we have, for example, f of x equals 3x minus 1 over 6x, and we want to find the horizontal asymptote. I'm going to be lazy and just abbreviate it. We all know what that is, right? We want to find the horizontal asymptote, but we want to apply our new skills using this idea of limits. So we would want to take our function and we would again say the limit as x approaches infinity for f of x equals, if we're looking for the limit as x approaches infinity, in our equation we're simply plugging in infinity. So it's the same thing as what we've been doing all along. But there's a few things that I'll sort of go over with you to consider as we're working our way through this. Over 6 times infinity. Oh, that was awful. Over 6 times infinity. So let's sort of think our way through this. At the top, do you see that if we have 3 times infinity and we take away 1 from it, the 1 is basically like not even significant. Does that make sense? Because if you put it into perspective, what we're comparing it with, it doesn't stand a chance. It doesn't have an impact at all, right? So we can pretty much just ignore that. So in a sense, we could look at this and say that we're working with 3 infinity over 6 infinity. I don't know why I'm having such troubles drawing that. So really, because you have that going on top and bottom, do you see that we can simply simplify this to say that it's just equal to 1 over 2? That's basically the concept or the idea behind it. So to put this into perspective, y equals 1 over 2 is our horizontal asymptote. If we were to sketch it out, if we went above the x-axis to y equals a half, we'd have that dotted line, and that's where it would occur. Questions are pretty straightforward. so far? Let's do another one. Let's say, for example, we want to find all asymptotes of f of x equals 1 over 2x minus 3. So there's a little bit of built-in review into this, because just to start off, without doing anything with limits or without giving it all that much thought, step number 1, let's think of or look at or analyze what the vertical asymptote would be. Just by looking at it, can you guys tell me? When does a vertical asymptote occur again? Using our past knowledge, just analyzing the equation. At x equals, do you see that we would look at the bottom here? So it's going to be 3 over 2, which if we took that, set it equal to 0, we know it's not allowed to be 0, and that's how we're getting this, right? So just some review. I know that you already kind of know that. And then for 2, we want to now move on to the horizontal asymptotes. And this is where we do get to practice our new skill here. So as x approaches infinity, okay, so let's go through some strategies. I'm looking at 1 over 2x minus 3. I think this part's going to be new to you. A strategy to simplify this, because do you see at the bottom, if I just plugged in infinity, it's going to be like 1 over infinity. Like the rest of it's like pretty negligible or not really. So here's a strategy that we can use to simplify this, and you'll see this come up often. Do you see that if I multiply by 1 over x, top and bottom, I haven't actually changed anything, right? Technically, we're just multiplying by the number 1, which doesn't change anything. But in doing this, I'm going to be lazy and just carry on this way. So in doing this, I'd have the limit as x approaches infinity of 1 over x is what I would get at the top, over 2x over x minus 3 over x. And to try to clear this up, I'm going to try to color code this and keep things straight. Making sense so far? Okay, and then why would we do this? Well, we can see here that these guys can cancel, right? So that simplifies things a little bit there. And then if I go to plug this in, if you look at this part and I plug it into my equation into here, I would get 1 over infinity over the 2x over x, they canceled, so I'm just left with the number 2, minus 3 over infinity. Whoops, minus 3 over infinity. Thinking our way through this, if you have any number and you're dividing it by infinity, what's your result going to be? Pardon? 0. Does that make sense to everyone? So that would be wiped out and would give us 0. That would be wiped out and would give us 0. I mean, we don't actually need to do anything with this, because if you have 0 over 2, we know that overall our answer would be equal to 0. So the limit as x approaches infinity of this 1 over 2x minus 3 ended up being equal to 0 is what we're saying. Yes?
So instead of doing like almost this, can we just plug infinity to next to 2? And start like 2 infinity minus 3. Like 1 over 2 infinity minus 3.
You could. This skill or thinking of this will come in handy with other stuff. So this one's pretty straightforward, so you're able to do that and get away with it. So I wanted to teach you this so that you're familiar with it and you'll see it come up often.
Okay.
Yeah, good. But in this case, yes, you're right. You can just do the straightforward plugging in. Well, I think that's it, everybody. Page 222, numbers 1 to 5 all, but don't graph them. I think it says in some of them to graph it, but you don't have to do that.